or you have taken a rest for 3 days already. So it's time to do a new task. So last week we have learned that the chemistry in the simple chemical cell. A simple chemical cell involves an electrolyte and two different metal. One is more reactive, another one is less reactive. The electrolytes can provide mobile ions to conduct electricity, and for the voltmeter here, the apparatus here should be voltmeter, which tells the direction of the electron flow. And if the voltmeter give a positive value, that means the metal connected to the negative pole will be the negative electrode, and the metal connected to positive will be positive electrode. So zinc is the negative electrode, and it also makes sense to what we have learned before, because zinc is more reactive. Zinc is more reactive than copper, so zinc will lose its electron more readily, and the electron will come out from zinc and pass through the voltmeter and then go back to copper. Okay, and then go back to through copper to the electrolyte. Okay, this is what we have learned. Okay, so look at this table on page 8. For case number 1, if we connect copper to the positive electrode and magnesium to the negative. Okay, so copper to the positive, and we use the electrolyte. We use one electrolyte for all of these 5 cases. Okay, and this one, magnesium, we use magnesium to be the negative electrode, and then it gives a positive value, so that we know because it's the voltage we get is positive, so that we know magnesium will be the negative and copper will be the positive electrode, just like this one. The negative and positive in the voltmeter. Okay, and then we know that the electron will flow from magnesium to copper, and when it comes to second case, when it is zinc, the voltage is still positive, so that it's flowing from zinc to copper. Okay, and the third case, when it is iron, it's still positive, so it will flows from iron to copper. But when it comes to both are the same, copper and copper, because the voltage is 0, so that we know there is no electron. Very bad handwriting. Okay, so no electron flow. Okay, and when it comes to silver and copper, it's negative. If it's negative, that means, okay, now it's no longer magnesium, it's silver. Okay, it's silver here. It's silver, and then it's negative, that means it's not negative electron, it's positive, and this one will be negative, so the electron flows from copper to silver. Okay, and this will also similar to this question. Okay, because the voltage for magnesium copper cell is positive 1.3. Okay, and that for zinc copper cell, which is only positive 0.9, and those who have submitted the work to me all get it correct, because the voltage of magnesium copper cell is higher than that of a zinc copper cell, so that we know magnesium is the most reactive, and the next one is zinc, and the next one is copper. Similarly, using this method, by comparing these voltage, we can arrange this metal to a series, and this series will be similar to the reactivity series. It's also talking about the tendency to lose electron, and we call it electrochemical series. In short term, we take E, C, and S. so we call it E.C.S, okay, electrochemical series. We arrange these metal in an order according to the voltage. Okay, we compare the voltage of the chemical cell we obtained when we change the metal here, and for this another one we don't change it, we keep it the same, and then we compare the voltage, then we can arrange the metals. Okay, then the ranking of the metal we call it E.C.S, okay, electrochemical series, and it's we arrange them according to the voltage. Okay, so but actually we don't use copper. Okay, we don't do it like this. This is just an example. In real case, we use hydrogen. We use the standard hydrogen electron. So what it is, in one of the half cell we have hydrogen ion and hydrogen gas at the same time, and it will be connected to a voltmeter and connected to a metal in electrolyte to make it to be a fair test. Electrolyte, okay, to make it to a fair test, this electrolyte we will use the same one, we won't change it. Okay, and then if so we connect different metal here. If the metal is reactive and they loses electron very readily, they like losing electron, then the electron will flow out from the metal and flows to hydrogen. Then the hydrogen ion will be, because there are a lot of electron here, and then there is negative charge, because it's negatively charged, so the positive hydrogen ion will be attracted and gain electron to form hydrogen gas. Okay, but when it comes to, if the metal is not reactive, less reactive than hydrogen gas, then hydrogen gas will lose its electron. The electron will hydrogen gas here will lose its electron, and then the electron will pass through the will reach the electric wire, and then pass through the external circuits through the voltmeter, and then go back to metal, and then the electrolyte will accept the electron. Okay, so we use the hydrogen cell to be the fixed one. Okay, we fix this one to be the same electron, and then we keep changing the metal. We only change the metal, and then we measure the voltage, and then we arrange the metal according to the voltage we get, and this is the real E.C.S we get. Okay, so you can look at this, compare it with the reactivity series we learned in Form 4. You will find that they are very similar with each other. Please stop calling me and then here is a cute zebra, right? Cute refers to C, which is carbon, and go on your song, zebra. Okay, please stop calling me a cute zebra, and then I like blah blah blah, and then make your own sentence. Okay, and discussion 6, why are the position, the ranking of metals in E.C.S and the reactivity series are very similar to each other? Because both are related to the tendency of losing electron. The easier it loses electron, then the higher position it will have. Okay, so if it loses electron easily, then the voltage of the battery will be very high, and also the metal is very reactive metal. Okay, but still there is some difference. When you look into these two series carefully, you will find that the calcium is higher than sodium in E.C.S, but lower than sodium in the reactivity series. Why they are different? Because they are measured using different method. They are measured using different method. Do you still remember how we measure? What do we measure? And then we get E.C.S. We measure the voltage, right? So E.C.S is based on the voltage obtained when the metal is used as electrode, okay, in the chemical cell. So E.C.S is based on the voltage we measured when we use that metal to be the electrode, okay. And metal reactivity series is based on the vigorousness of the reaction involving that metal, okay. For example, the metal, okay, for example, magnesium plus hydrogen ion will give a hydrogen gas, and then it will change to magnesium ion. Then we measure how vigorous the hydrogen gas is given out. We measure the rates of the hydrogen of the formation of the hydrogen gas. The faster the hydrogen gas is given out, then we say that the metal is very reactive, okay. So the reactivity series is based on how vigorous the metal can react and how fast is the rates when the metal reacts, okay. So that's why they are different, although they are very similar with each other. So in conclusion, this task we learn E.C.S, okay, electrochemical series. So if now we have a battery, a simple chemical cell like this with two different metal and an electrolyte, so any electrolyte, right, and then we're using two different metal, if metal 1 and metal 2, okay. If I choose magnesium to be metal 1 and then silver to be metal 2, and then for another battery I use same to be the metal 1 and silver to be metal 2, then which chemical cell will has a higher voltage? Then we should know that the chemical cell using this one, the red one, using magnesium and silver will has a higher voltage than that using copper and silver, because magnesium has a higher position than zinc in the E.C.S. Okay, to explain why it has a higher voltage, because magnesium has a higher position than zinc in the E.C.S. That's why the chemical cell involving magnesium and copper will has a higher voltage than that using zinc and silver, okay. So in this task we learn E.C.S, and your task is to complete the next 2 pages of exercise 1 on page 10 and page 11. That's all. Please work hard